Hello everyone. Today we are going to study the theory of earth pressure, or it is also known as lateral earth pressure. So what is basically earth pressure and where is its application lies? Mainly earth pressure is used for designing various types of retaining walls, sheet piles, breach abutments, bulkhead, any kind of basement wall or other type of earth retaining structure. In this type of structure, it is of very much necessary to compute the lateral pressure which is exerted by the retained mass of soil. So here, what is the application of earth pressure? Most of the time, the application of earth pressure is used for design of retaining wall. So what is retaining wall? A retaining wall or retaining structure, it is used for maintaining the ground surface at different elevations on the either side. So here in the diagram, you can see the various uses of retaining wall. That is retaining wall used for embankment, in case of cutting, in case of breach abutment, for water storage, and other uses also includes flood walls for reducing flood as well as sheet piles wall. So these are the application of retaining wall. So the material which is retained or supported by the structure or the retaining wall is known as backfill. So this backfill may have its top horizontal or inclined. In this figure, you can see the backfill earth or the soil is horizontal. But in case of embankment and the cut, it is inclined. So it varies depending upon the areas where the retaining wall is being used. And the position of the backfill lying above the horizontal plane at the elevation of the top of the wall is known as subcharge. So as we will go through the chapter, we will going to study about this terminologies related to retaining wall. So for lateral soil resistance, what are the applications in geotechnical engineering? In cantilever retaining wall, it is used for retaining the lateral soil, then for breast excavation and for anchored sheet pile. In all these type of structures, soil retaining is the most important part of the design. So let us go to the definitions of the key terms that are used for defining the earth pressure. So there are three type of key terms that are used in this chapter, that is active earth pressure coefficient, passive earth pressure coefficient and coefficient of earth pressure at rest. So what are these things? Active earth pressure coefficient is a ratio of horizontal and vertical principal effective stresses when a retaining wall moves away by a small amount from the retaining soil. So here we will study consecutively that the active earth pressure coefficient is nothing but the ratio between the horizontal and vertical principal stresses. So when does active earth pressure takes place? It takes place when the retaining wall which supports the backfill, it moves a slight away from the backfill. So next is the passive earth pressure coefficient. So passive earth pressure coefficient is defined as a ratio of the horizontal and vertical principal stresses, and in this case it is reversed of the active earth pressure case. That means the wall is forced against the soil mass. And what is coefficient of earth pressure at rest? As the term suggests, rest. So it is also the ratio of the horizontal and vertical principal effective stresses being the condition given that the wall is at rest. That means there is no lateral movement between the soil and the retaining wall. So these are the three key terms. So let us go through the basic concepts related to lateral earth pressure theory. So in the lateral earth pressure theory, we have to consider that that the lateral earth pressure is applied on one side of the retaining wall. That means retaining wall retains a part of the soil only on its one time, on side. So first of all, for finding out the theory of earth pressure, we will consider the drained case. So what is the drained case? In drained case, the shear strength of the soil is mainly governed by its angle of internal friction. So these cases, drained and undrained, you have already studied in soil mechanics 1 in triaxial test. So for finding out the earth pressure theory, we have to follow some assumptions. So what are these assumptions? The interface between the wall and the soil will be frictionless. The soil surface will be horizontal and there will be no shear stresses on the horizontal and the vertical plane. That is, the horizontal and vertical stresses will be the principal stresses. The wall will be rigid and extended to an infinite depth in a dry, homogeneous, isotropic soil mass. And the soil will be loose and initially at rest condition. So these are the assumptions based on which the earth pressure theory has been developed. So this earth pressure theory has been developed in two main branches, or the two theory that are being predominated for presenting the earth pressure has been given by Rankine and Coulomb. So there are two earth pressure theory. One is the Rankine earth pressure theory and the other one is Coulomb earth pressure theory. So what are the assumptions do Rankine make for finding out the earth pressure? And the Rankine's assumptions are there is no adhesion or friction between the wall and the soil. The lateral pressure is limited to vertical walls. Failure occurs as a sliding wedge along an assumed failure plane defined by phi. Lateral pressure varies linearly with depth and the resultant pressure is located 1/3 of the height above the base of the wall. The resultant force is parallel to the backfill surface. So mainly, as originally proposed, Rankine theory of lateral earth pressure is applied to uniform cohesionless soil only, but later it was modified and the cohesive soils also been included in the Rankine's theory. So next we will go to Coulomb's theory. So what does Coulomb assume? The Coulomb theory is quite similar to Rankine theory, but there are few exceptions. So what are these exceptions? So there is a friction between the wall and the soil, and that takes into account by using a soil wall friction angle delta, which in Rankine case we used to consider that the friction between the wall and the soil will be zero, or it will be frictionless. Again, the value of this delta ranges from 5/2 to 2/5/3, and most of the cases 2/5/3 value is commonly used. And this lateral pressure is not limited to vertical walls only. That means the wall can also be inclined, not necessarily vertical wall has to be used. And the resultant force is not necessarily parallel to the backfill surface, as because the soil wall friction value is delta. That means there will be nothing as such that the resultant force will be parallel. It may change depending on the value of delta. Hence, there is a slight bit of difference between the Rankine theory and the Coulomb theory. We are going to study both theories consecutively. So let us go through the case where the earth pressure is in the rest condition. So we will study that the earth pressure at rest condition. So when the earth pressure is at rest and this earth pressure is exerted on the back of a rigid, unyielding retaining structure, the value can be calculated using the theory of elasticity, assuming that the soil to be semi-infinite, homogeneous, elastic and isotropic. And if the wall is rigid and does not move with the pressure exerted on the wall, the soil behind the wall will be in a state of elastic equilibrium. So from the figure it can be identified that it has been considered a small soil element which is situated at a depth z from the ground level, and where the vertical stress sigma b v and the horizontal stress sigma h are acting on it, there will be no shear stress. So the earth pressure at rest corresponding to the condition of zero lateral strain is given by sigma h by sigma v, where sigma h is the lateral pressure and sigma v is the vertical pressure. So this sigma h by sigma v is given as K naught, where K naught is the coefficient of the earth pressure at rest. So from there, the lateral earth pressure at rest is indicated by sigma h, and the value of sigma v is substituted as gamma into z, where gamma is the unit weight of the soil and z is the depth of the soil. So we have the value of the lateral earth pressure sigma h acting on the wall at any given depth z is given by sigma h equals to K naught into gamma into z. So this is the value of the earth pressure at rest condition. So as per the pressure distribution diagram, we can easily see that pressure distribution diagram is triangular, where the value of the pressure or the intensity of the pressure at top is 0, where depth is 0, and the intensity of K naught into gamma h at the base of the wall. So the diagram will be triangular. Hence the total pressure acting on the total length of the wall is given by P naught equals to half of K naught into gamma into h square. And this intensity of pressure will be acting at a depth of h by 3 from the bottom of the retaining wall. So this is the value of the total intensity of earth pressure at rest. And the value of the earth pressure coefficient K naught can be also computed from the following approximate equation, where K naught is equals to 1 minus sin phi and K naught equals to mu by 1 minus mu. So this is the theory of earth pressure at rest. So what are the factors which affects the value of K naught? The factors which affect the value of K naught depend upon the relative density of the sand and the process by which the deposit has been formed. So if this process does not involve artificial tampering, the value of K naught ranges approximately from 0.4 for loose sand to 0.6 for dense sand. And if the layers has been disturbed or tampered, this value may increase to 0.8. So hence this is the theory, basic theory regarding the earth pressure at rest.